So this is actually the third time that I've been trying to do number 6 and I keep messing up, so hopefully this one will be right. So this is essentially what the original equation is, just in a nutshell. When time equals 0, x is -6, that's the original equation, and I'm changing the x now from my equation to an x equals -4. So for a, very simple, I need to find s of t. So I take the integral of 3t squared 12t dt. Powering up and dividing is very simple, so it would just be t cubed minus 6t squared plus c, and then when time equals 0, when you plug in 0 for t, then c would become -4. So then, knowing that, our original equation would be this. And that's it, right? B, it's asking the direction in which it starts and if it changes. So for that, I take the velocity and set it equal to 0. So then that would be t minus 4 after I factor out of 3t. T would equal 0, and this would be 4. Now, we have to make the chart. Time cannot be negative, obviously, but it can go on for forever. So a V with a 1 and a V with a 5. When you plug in 1, it would be negative because the 12 would beat the 3. And then it would be positive over here. So it would be left and right, or negative and positive. So what that means is it starts going left or backwards, and then at 4, or when time equals 4, it will change direction and be positive. Now for C, let me see, where's the, okay, it says find the distance traveled in, it says 8 seconds, I'm just going to change that to 6, so find distance traveled after, or when t equals 6, they said 8, I'm changing it to 6. So with that I need s of 4, because it's going to change. I need to find distance, but the thing is, some of it is negative. All this is negative, so I need to absolute value it. And then minus s of 0 plus s of 6 plus s of 4. It's almost like a b minus a sort of deal. And so I'd get, when you plug in 4, you would get a -32. Yeah, -32. And then plug this into my calculator, and s of 6 you would also get, well, you'd get a positive 32, and so your answer would be 64 units. And that is it for 6. So this is 7. The original's on top. I just changed b to 3 and a to 0. Changed it to an x minus 2, and then to the radical of 3 minus x dx. So I need a u because there's a radical. So I'm going to set u equals to what's under the radical. Du would then equal just negative dx. So what I have over here is a 3 and a 0 still. X minus 2 would stay, and there would be a radical u, but then our du demands that there's a negative x. So we need a negative here, and then a dx, which means we need a negative on the outside. So simplified again, it would just be, that's not supposed to be that negative. So then it'd be a negative on the outside, then an x minus 2 would stay, radical u du. But we still have an x, so to get rid of that, we have to organize this around what x would equal is a negative u plus 3. So we plug that in. Negative u plus 3 minus 2 times the radical u du. And we'd get a negative u plus 1 square root of u du. To take the antiderivative, we have to get 1, well, we just push this in, distribute. So it'd be a negative 3, 0 to the negative u to the 3 halves plus square root of u, or u to the 1 half, du. I'll just change that real quick, u to the 1 half. And so, but then our values here are for x, so when x equals 3, u equals 0, and when x equals 0, u equals 3. So now we have this, just kind of flipped it. But to flip the a and b, we need to multiply times the negative, and at the same time I'll integrate these. So first we'd multiply times the negative, that would become a positive. Then these would switch, and I'll show that in the next step. Those are the arrows to show that that switches. This we'd power up, so it'd be a 5 halves, but then you have to divide by that, so it'd be a 5 halves, negative, and then 5 halves on top, but then 2/5 because you have to divide by the or by it, which would flip it over, and then u to the 5 halves plus 2/3 u to the 3 halves plus c, but that's gone because we're plugging in 3 and 0. And so now when you plug in 3, this is some crazy math. When you plug in, I'm going to move this up here, you get negative 2/5 times 3 to the 5 halves plus 2/3 times 0 to the 3 halves. So this is gone, and now we can just focus on that part. So I guess I would just leave it in that form. I can plug it into my calculator as well, but it would just be, if I plugged into my calculator, I would get in a decimal form, I get negative 6.235. This technically are the same thing, but that's essentially my answer for that problem. That's the original on top again, and all I'm going to do just seems like it will work out easy, but still have the same difficulty, as I'm just going to switch these two and see what happens. So I'll set u equal to this because it seems like the best place to start. Du would then be a cos t dt, and that works perfectly. I think it actually worked out better than the one up there, but so that would cancel, and that would become a du. So in the end, we'd have a secant squared of u And then I believe, yeah. And then du, which, taking the antiderivative of that, it would just be tan of u plus c, which would then equal tan of sine t plus c. And that's our answer for B. Pretty simple. Okay, I gotta film this last one real quick. So, just change sine to cos. I'm running out of space on my memory. Setting u equal to 2x, du would equal 2 dx. Gotta put a 2 there, then a 1/2 on the outside. 1/2 of cos of u du is what we're left with, k0. So it would be a 1/2 of sine, 2x should come back in for the u, plus c, but then that would be k and 0. So 1/2 sine 2k, and then when you plug in 0, you'll get the sine of 0 is just 0. So you get minus 0, which would equal 1/2. So sine 2k has to equal 1. Therefore, 2k would have to be pi halves. The only other one is 5 pi halves, which is not fit in the integral, which means k equals pi fourths. Done.